This vehicle is taller than your house. Its tires cost $42,000 each, and it needs all 6 of them. It burns 150 gallons of fuel in a single shift. That's more than your car uses in 3 months. And when it drives past you, the ground shakes like a minor earthquake. I'm talking about mining trucks, the absolute monsters of the industrial world. But here's what nobody tells you about these machines. They're not big because engineers wanted to build something cool. They're not big because mining companies like showing off. They're big because of a mathematical problem that almost destroyed the mining industry in the 1950s. And the solution to that problem created the largest land vehicles ever built. Let me show you something that'll blow your mind. A Caterpillar 797F mining truck weighs 687 tons when fully loaded. That's the weight of 450 cars, or 5 fully loaded Boeing 737s. Its bed can hold 400 tons of rock. That's roughly the weight of 200 elephants. One truck, one load, 200 elephants worth of material. When you see one in person for the first time, your brain doesn't process it correctly. You think you're looking at a building, then it moves, and you realize you're looking at a vehicle. But why? Why build something this absurdly large when you could just use more normal-sized trucks? The answer goes back to 1950s Montana, specifically to a copper mine that was about to go bankrupt. The Bingham Canyon mine in Utah had a problem, a big one.
They were mining copper from an open pit, digging deeper and deeper into the earth. And every day, they needed to move thousands of tons of rock out of that pit. At first, they used normal trucks, dump trucks you'd see on any construction site. But the math wasn't working. Here's the issue. The deeper you dig, the farther trucks have to drive. A truck at the bottom of the pit had to drive up a winding road for miles just to reach the surface and dump its load, then drive all the way back down empty. Each truck was spending more time driving than actually hauling. They tried using more trucks. Didn't help, just created traffic jams on the narrow mine roads. They tried bigger engines and normal trucks. The trucks broke down from the strain. The mine was losing money every single day. Then an engineer named R.G. Letourneau had a crazy idea. What if we don't use more trucks? What if we build one truck so big it can carry what 10 trucks used to carry? Everyone thought he was insane. The logistics seemed impossible. How do you build a truck bigger than a house? How do you make tires that can handle that weight? How do you stop it from sinking into the ground? But Letourneau did the math, and the math was beautiful. If one massive truck can carry the load of 10 regular trucks, you only need one driver instead of 10, one maintenance schedule instead of 10, one engine to fuel instead of 10, one trip up the mine road instead of 10 trips.
The efficiency gains were staggering. So in 1963, Letourneau built a prototype, the Titan, a mining truck with a 200-ton payload capacity. It was ridiculous. It was excessive. It looked like something from science fiction. And it completely revolutionized mining. Within 5 years, every major mining operation in the world wanted one. But here's where the story gets really interesting. Building a truck this big isn't just about making everything bigger. You can't just scale up a normal truck, because physics doesn't scale linearly. Let me explain. If you double the size of a truck, you don't double its weight. You increase it by 8 times. That's the cube square law. Volume increases faster than surface area. So when you make a truck 5 times bigger, you're making it 125 times heavier. Suddenly, normal tires can't handle it. They'd explode instantly. Normal steel would buckle under its own weight. Normal brakes would melt trying to stop it. Engineers had to completely reinvent every single component. The tires? They're not rubber. Well, they are, but they're reinforced with steel cables woven through them like chainmail. Each tire takes an entire day to manufacture and costs more than a luxury car. And they still only last 6 months before needing replacement. The frame? It's not a frame. It's a massive steel structure engineered like a bridge.
The dump bed uses hydraulic cylinders that can lift 400 tons. Each cylinder can lift a fully loaded semi-truck vertically. And the engine? A Caterpillar 797F has a 4,000 horsepower diesel engine. For context, a Formula One race car has about 1,000 horsepower. This mining truck has 4 Formula One cars worth of power just to move itself. But here's the really insane part. Even with all that power, these trucks are slow. Top speed, about 40 miles per hour, and they take almost a full minute to reach that speed. Because you can't accelerate 687 tons quickly. The tires would literally rip apart from the torque. So why are they worth it? Let me show you the economics. A typical open pit mine needs to move about 400,000 tons of material every single day. Using regular 20-ton dump trucks, you'd need 20,000 truckloads per day. That's 20,000 trips, 20,000 driver shifts, thousands of trucks. Using 400-ton mining trucks, you only need 1,000 loads, 1,000 trips versus 20,000 trips. The difference in fuel cost alone is millions of dollars per year. Labor costs reduced by 95%. Road maintenance in the mine, way less because fewer vehicles means less wear. Suddenly, building a $5 million truck that burns $100,000 in fuel per year makes perfect economic sense because the alternative costs 10 times more. But there's something nobody talks about. These trucks are so big, they create their own problems. First, transportation.
You can't drive one of these on a public road. They'd crush the pavement. So how do you get them to remote mine sites? You build them on location. That's right. Caterpillar and Komatsu ship these trucks in pieces, hundreds of pieces. A specialized team assembles them at the mine site like the world's most expensive Lego set. It takes weeks. Second, the environmental impact is staggering. One of these trucks produces more pollution in a year than 30 normal cars combined. One single mine operation with 50 of these trucks is essentially running 1,500 cars 24/7. Third, they're terrifying to work around. Mining truck operators sit in a cab 3 stories off the ground. They have blind spots the size of school buses. There are documented cases of these trucks running over regular vehicles and the operator never even feeling it. Mines have strict protocols. When a mining truck is moving, everything else stops. You don't drive near it, you don't walk near it, you get out of its way. Because if something goes wrong, 687 tons doesn't stop quickly. So here's the question, could we make them even bigger? The answer is yes, technically. But we've hit a practical limit. The biggest mining truck ever built was the Liebherr T282C. It could carry 450 tons. Why didn't we keep going? Because at a certain size, you can't transport them even in pieces. The components become too large to move on any road or railway. You'd need to build a factory at every single mine site.
And the tires? We've reached the physical limit of what rubber and steel can do. Any bigger, and tires would need to be solid steel wheels, which would destroy mine roads and create other problems. So the current size, around 400 tons of payload, is where physics and economics intersect. It's the sweet spot where the truck is big enough to be efficient, but not so big it becomes impossible to build and maintain. But here's the final twist that'll make you see these machines differently. These trucks are autonomous now. Rio Tinto, one of the world's largest mining companies, runs entire fleets of these trucks with no drivers. Computer-controlled, GPS-guided, operating 24/7 without brakes. A truck that weighs 687 tons, carrying 400 tons of rock, driving itself through a mine. It's like if your house got up and drove to work every day. And this is the future. Within 10 years, most mining trucks will be driverless. The job that required a specialized operator making 6 figures a year? Gone. Replaced by a computer that never gets tired, never makes mistakes, and never needs bathroom breaks. The machine that was built to solve a 1950s labor problem is now eliminating labor entirely. So the next time you see copper wire, or steel, or the minerals in your smartphone, remember, all of that came out of a hole in the ground. And it was pulled out by a machine so large, it doesn't look real. A machine that exists because in the 1950s, someone asked a simple question.
What if instead of using more trucks, we just built one really, really big one? And that question created the largest land vehicles in human history. If this blew your mind, hit that like button. Comment below, would you drive one of these monsters, or does the idea terrify you?
And subscribe because next week, I'm revealing why airplane tires don't pop when they land at 180 miles per hour. The engineering behind that is absolutely insane.